Ever wondered how the tiny atom was first discovered and how our understanding of it has evolved over time? Buckle up as we embark on an exciting journey through the history of atomic theory, from the musings of ancient Greek philosophers to the cutting-edge advancements in modern science. Early philosophers' beliefs. Long before scientists donned lab coats, ancient Greek philosophers like Aristotle believed that everything was made up of four fundamental elements: earth, air, fire, and water. These early thinkers also speculated that matter could be divided infinitely without ever losing its inherent properties. Little did they know, they were setting the stage for one of the most profound scientific discoveries of all time. Democritus and the atom. Fast forward to 400 BC, when a Greek philosopher named Democritus had a revolutionary idea. What if matter could only be divided until reaching indivisible particles? He called these indivisible units atoms, derived from the Greek word atomos, meaning uncuttable. Although his idea was largely philosophical, it laid the groundwork for future scientific inquiry. Laws of chemical combinations. Jumping ahead to the 18th and 19th centuries, several key laws emerged that further shaped our understanding of matter. Joseph Proust formulated the law of definite proportions, which states that a chemical compound always contains the same proportion of elements by mass. Antoine Lavoisier introduced the law of conservation of mass, asserting that mass is neither created nor destroyed in chemical reactions. John Dalton proposed the law of multiple proportions, suggesting that elements can combine in different ratios to form different compounds. John Dalton's atomic theory. In 1804, John Dalton took a significant leap forward by formulating his atomic theory. Elements are composed of tiny, indivisible particles called atoms. Atoms of the same element are identical in mass and properties. Atoms combine in simple whole number ratios to form compounds. Chemical reactions involve the rearrangement of atoms. Dalton's theory provided a solid scientific framework that would endure for centuries. The late 19th century brought the discovery of the electron. William Crookes discovered cathode rays using a Crookes tube. In 1897, J.J. Thomson demonstrated that these rays were streams of negatively charged particles, which he named electrons. He proposed the plum pudding model, which depicted the atom as electrons scattered within a soup of positive charge. In 1911, Ernest Rutherford conducted his famous gold foil experiment. His observations led to the discovery of the nucleus, a small, dense, positively charged core at the center of the atom. Rutherford proposed a new atomic model where electrons orbit the nucleus, much like planets around the sun. Discovery of the proton and neutron. Further advancements came with the identification of two more subatomic particles. In 1919, Rutherford discovered the proton, a positively charged particle within the nucleus. In 1932, James Chadwick discovered the neutron, a neutral particle also residing in the nucleus. Properties of subatomic particles. By now, we understand that atoms consist of three primary subatomic particles: electrons, which are negatively charged with a very small mass; protons, which are positively charged with a relatively large mass; and neutrons, which are neutral particles with a mass similar to that of protons. Understanding atoms also involves some key concepts. Atomic number, symbolized as Z, is the number of protons in the nucleus defining the element. Mass number, denoted as A, is the total number of protons and neutrons in the nucleus. Isotopes are atoms of the same element with different mass numbers due to variations in the number of neutrons. The atomic theory has come a long way from the speculative ideas of ancient philosophers to the sophisticated models of today. Through pivotal experiments and groundbreaking discoveries, we've unraveled the complex structure of the atom and identified its subatomic components. The concept of isotopes and the development of mass spectrometry have further refined our understanding, allowing us to analyze elements with incredible precision. From the musings of Democritus to the meticulous experiments of Rutherford and beyond, the story of the atom is a testament to human curiosity and ingenuity. As we continue to explore the subatomic world, who knows what new discoveries await? Stay tuned, science enthusiasts. The adventure is far from over.